Okay, welcome to our class. In last class, what we are started electronic configuration. We are discussing electronic configuration in different elements whose containing their atomic number range lies from 1 to 30. So yesterday I explained up to 15, atomic number 15 phosphorus. Okay. Today we are going to discuss remaining elements electronic configuration. See, element, atomic number, write down atomic number is represented with letter Z. So always you remember atomic number is Z. That Z indicates the presence of electrons in neutral atom. Electronic configuration. Electronic configuration. Electronic configuration. So yesterday we studied up to phosphorus atomic number 15. Then after 15, what is our element? Coming element is sulfur. Sulfur. So sulfur symbol is S. Sulfur atom or element represented with symbol S. Atomic number is 16. Atomic number is 16. So you want to write the electronic configuration. So then first one 1s2, 2s2, 2p6, 2s2, 2p6, then 3s2, 3p6. See 1s2, 2s2, 2p6, 3s2, 3p4. Come on, you count the atomic number is 16 means in sulfur atom how many electrons are there? 16 electrons are there. So you can accommodate 16 electrons from lower energy orbital to higher energy orbital. Already you know what is lower energy orbital, what is higher energy orbital. So just you write the configuration 1s2, 2s2, 2p6 up to this 10 electrons we arranged. Remaining 4 plus 2 16, 3s2, 3p4, isn't it? Okay. Then after sulfur, next atom or element is chlorine. Symbol is Cl. Atomic number is 17. So atomic number 17 means 17 electrons are present in chlorine neutral atom. So you remember one thing, atomic number which is equal to number of electrons equal to number of protons in case of neutral atom. Okay. So 17 means then you can arrange the electrons like this. What is this configuration? 1s2, 2s2, 2p6, 3s2, 3p5. Okay, like it. Then after chlorine, the next element is chlorine after argon. Our element or atom is argon, symbol Ar. Atomic number is 18. What is atomic number of argon? 18. You remember? Okay. So listen carefully, students. While running the chemistry class, you should maintain class notes and you can read number of times, read and write. Then you get perfection. Good. See, argon atomic number is 18. That means how many electrons are present in argon atom? 18 electrons. So you can arrange electrons as per their energy orders. That is called what? Electronic configuration. See, 1s2, 2s2, 2p6, 3s2, then 3p6. Just you can count electrons 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18. Okay, that's it. This is the configuration of argon. Okay, after argon, atomic number 19 element. What is that? Potassium. Potassium symbol is K. Potassium symbol is K. Symbol is K. Then atomic number is 19. That means 19 electrons are present in potassium atom. So you write configuration like this: 1s2, 2s2, 2p6, 3s2, 3p6. That means here each subshell contains 3 orbitals px, py, pz. Each are orbital accorded to electron. That means p6 subshell is over. After p6, third 3s2, 3p6. After 1s2, 2s2, 2p6, 3s2, 3p6. The next higher energy orbital is 4s. 4s1. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay. Here, students, here with this configuration, I write here short notes of short notation of electronic configuration. See, so up to this 1s2, 2s2, 2p6, 3s2, 3p6. This is nothing but what you know, argon configuration, no, argon 18 configuration, no, 1s2, 2s2, 2p6, 3s2, 3p6. This is called argon configuration. So up to this is argon electronic configuration. Argon electronic configuration. Okay. So in place of entire this place, instead of this, I write argon simply. Argon 18 4s1. So 18 plus 1, how much? 19. No? This is called what? Short notation. Short notation of electronic configuration. This is called short notation. Short notation. Okay. You write down both. Both are right. So whenever you want to express in short manner, you write like this. Whenever you want to express the right configuration in a long manner, you write the above one. Okay. So in higher studies, you will write the configuration like this. Okay. This thing you remember. Both are right. The above one is right and below one is right. This is complete configuration. This is short notation configuration. Okay. Then after calcium, next element is calcium. Calcium is symbol Ca. Ca. Atomic number is 20. You know, 20. So whenever you want to write the configuration, see long configuration. I write long configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. See here, if you want to express the same configuration in short manner, see instead of this, just you put argon atom, argon. So you know argon. What is that argon? Atomic number 18. Then you write first 18 plus 2, 20. Okay, isn't it? Have you understood this? Write down. So the above one is a long expression of the electronic configuration. The below one is short expression for configuration. Okay, electronic configuration. So far we are studying up to 20, atomic number 20 elements, you know. But in your syllabus, we will be having electronic configuration up to 30. Up to 30. So the next 21st element, 21 element is scandium. 22 elements is titanium. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. These 10 elements are actually D block elements. Their atomic range lies from 21 to 30. Okay, that is also is a part of your 9th 10th syllabus. So essential to read and write this configuration. After completing this, we go and discuss those electronic configurations. Okay, I want to remove this. Have you written up to this? Did you write? I want to remove. Okay. So here one thing you remember, whenever you want to express the scandium up to zinc D block elements electronic configuration, just we use argon short configuration. Okay. So argon configuration is this one: 1s2, 2s2, 2p6, 3s2, 3p6. So instead of this, just you keep just only argon. Okay. Then I write here So it is very easy to understand. The next element is scandium. Scandium. So what is the symbol of scandium? Sc. Scandium. Atomic number is 21. Atomic number is 21. See, I want to write for your clear understanding. I want to write long expression. So what is that long expression? 1s2, 2s2, 2p6, okay, 3s2, 3p6, then after 4s2, okay, then after 4s, here 4s subcell is completed. No, after 4s, the higher energy, next higher energy subcell orbital is what is that 3d? So it is 3d1. So this is a long expression. Electronic configuration expression in a long manner. But whenever you want to express in short manner, so instead of this, up to this, you put order. Simply you put order. This is 18, no? 18, 4s2, 3. That's 4s2, 3. Actually, in higher classes, you will write like this configuration. Okay, write down. After scandium, the next element is titanium. Titanium. That means Ti. Titanium is Ti. Atomic number is 22. Then you want to write the configuration. The very simple thing, you know, simply you put argon 80. Okay, 4s2. Just you can add one electron 3d2. That's all. Okay. From scandium onwards, you can write only short expression. No need to write complete electronic configuration. Okay. After titanium, vanadium. Next element is vanadium. Symbol is V. Vanadium. Atomic number is 23. So just you write configuration, short configuration like this, argon 80, just 4s2, PD3, you know. Moreover, I already told to you, D subcell contains how many orbitals? 5 orbitals. 5 orbitals. dxy, yz, zx, x square minus y square, z square. 5 orbitals means each orbital accounted 2 electrons. 5 2s are 10 electrons. So D have D orbitals, D subcell having 5 D orbitals and total of 10 electrons. So after vanadium, the next coming element is chromium. Chromium, Cr. So atomic number is 24. So here, if you want to write the configuration of chromium, just like this, you put argon, write 4s2. What is this 3d4? 3d4. But here one important thing is there. In case of chromium, what happens? One electron promote from s orbital to d orbital. Promote from s orbital to d orbital. By that, what happens? Chromium electronic configuration should be like this. Why? Because one electron promoted from s orbital to d orbital. By that, actual chromium configuration will be like this: 4s1, 3d5. You remember this? This type of configuration, what we call, this is anomalous configuration. This is special configuration. What is this? Anomalous or special configuration? Anomalous configuration. This is called anomalous or special configuration. Special configuration. Anomalous or special configuration. Why this is happened? Actually, you can't understand this phenomena at this lower standard. You will be understanding in intermediate. This one you will understand in intermediate classes. Okay, just as it is, you have to remember what is that configuration of chromium is actually 4s2 3d4, but the anomalous and special configuration acquired by chromium. Why? Because one electron from s orbital promotes to d orbital for acquiring stability. Why this is happening means for attaining the stability. That thing you remember. Deeply, you will understand in higher classes. Okay, then after chromium, the next element, 25th element, manganese. Manganese. Manganese, Mn. Atomic number is 25. So what is this configuration? Just you write argon 18, okay, 4s2, 3d5, 4s2, 3d5. And just you can count students, 25 atomic number means 25 electrons. Just you can count 18 plus 2, 20 plus 5, 25. That's it. Here, write down quickly. Don't waste your time. That's what I am writing here. The same thing you copy down quickly. Okay, then next. I want to write next following element after manganese, iron. Iron. Iron atomic number is 80, atomic number is 26, and the configuration should be like this: 18, 4s2, 3d6. That's all. 4s2, 3d6. After iron, the next element is cobalt. Cobalt symbol is CO. So you students, you try to observe here. CO means this O. You write small O. You write here. If you write O in a big, that is carbon dioxide. That becomes carbon dioxide. Okay. While writing cobalt, you put O, small O. You put. Okay. Atomic number is 27. That means 27 electrons are there. So what is this configuration? See, argon 18, 4s2, then 3d7. That's all. Okay, after 27, nickel. Coming element is nickel. Nickel, symbol is Ni. Symbol is Ni. Atomic number is 28. That means 28 electrons present in nickel atom. So I write configuration like this: 18, 4s2, 3d8. That's it. 4s2, 3d8. See, listen, I give you one short expression. See, shortcut. See, here 8 is there, no? This 8 is right on D subset. You have to write 8 on D subset. That means you put 8 on D subset, and you put 2 on S subset. So 27 is there, no? 7 on D, 2 on S. 26 is there, no? 6 on D, 2 on S subset. Argon is common, you know. This is the way to remember in a short manner. Understood what I am saying? Okay. After nickel, next element is copper. Cu. Atomic number is 29. Then configuration should be 4s2, 3d9. 4s2, 3d9. But in case of copper is also electronic configuration similar to chromium. What you have studied just now in chromium, there is an exceptional configuration, anomalous special configuration. The same thing is happened in copper also. Here what happens? See, one electron from s orbital promoted to d orbital. By that what happens? Configuration becomes like this. See, argon 19, you know, this becomes 4s1, this is 3d10. This configuration we call as what configuration is? Anomalous or special? Exceptional and special configuration. This is not anomalous. Anomalous configuration. Okay? You remember this. This is exactly similar to that chromium. What happened? In chromium, there also what happens, one electron promoted from s orbital to d, so that there becomes 3d5. Here d subshell becomes d10. Why this situation arises in case of chromium and in case of copper means for attaining stability. For attaining stability. So in higher studies we come across one rule. What is that? Half-filled orbitals and full-filled orbitals are stable. Half-filled orbitals, full-filled orbitals are stable. That means here D10, no? D10 means D subshell is having how many orbitals? 5 orbitals, you know. 1, 2, 3, 4, 5 orbitals. So for example, one electron accommodated in one orbital like this. This becomes what configuration? D5. So half-filled orbitals are stable. This is the one phenomena. Okay, one phenomena identified by the scientist earlier. So this is D5 and D10 means what is D10? D10 means and all are pair up. All are pair. This is full-filled configuration. No? So here the thing you remember: half-filled orbitals and full-filled orbitals. The atom whose contain half-filled orbitals and full-filled orbitals are stable in nature. So for attaining stability, here chromium and copper, in chromium and copper, what happens in these two atoms means one electron from s orbital promoted to d orbital. In chromium, promotion of electron from s orbital to d orbital, what happens? It acquires d5 configuration. In case of copper, due to promotion of one electron from s orbital to d orbital, what happens? It becomes d10. That means d5 and d10, half-filled and full-filled d orbital configured atoms are stable in nature. So for attaining stability, those two atoms acquiring special anomalous configuration. Did you understand? I think you have understood very well. You write down this. If not, you don't bother about this. If not, you can't understand, you don't bother about it at this stage, because you are at 9th and 10th standard. No need to discuss. But in higher studies, intermediate, we will discuss again and again. Okay. Then after copper, the last element is zinc. Atom or element, both are right. So one thing, students, one thing you remember: atom is small one, element means bigger one. Okay, element is composed of so many number of atoms. For example, zinc is a bigger one. It contains so many number of zinc atoms, small atoms. So what is the atomic number of zinc? 30. So if you want to write the configuration, the configuration of zinc should be like this. See, this is argon 18, argon 18, not 19, 18. So here argon 18, then 4s2, 3d10. Come on, here atomic number 30 means how many electrons present in zinc? 30. So I can arrange here 30 electrons like this. 18 plus 2, 20 plus 10. How much? 30. So this is the configuration, actual configuration of zinc. Okay. Regarding here, one important note I tell you. One important note you write down. What is that? Chromium, copper, zinc. Atoms are stable. Why? Because these are having half-filled and full-filled orbitals. Okay. Here chromium is having D5, copper is having D10, zinc is having also D10. So here chromium, copper, zinc atoms are stable due to D5, D10 configuration. D5, D10 configuration. This note you have to write down in your running notes. Students, you have to write down these notes. Okay, this point you copy down. See, students, from 2 days onwards, what I have been explaining, I am explaining I am explaining valence cell, penultimate cell, anti-penultimate cell, valence electrons, core electrons, and also how to the way to write the electronic configuration of different elements whose atomic number from 1 to 30. Okay, during this configuration I am explaining what is the short expression of electronic configuration also we studied. Okay, with this we completed the special topic regarding atomic structure. Okay, I stop here. Remaining part we will continue in the next class. Thank you. See you.